Hello everyone, I am Soumyashree Senapati, Assistant Professor, Vedang Institute of Technology. In our previous classes, we have already discussed about how to derive hoop stress and longitudinal stress. So, in this class, we will solve some numericals related to our hoop stress and longitudinal stress. So, before going to solve the problem, we need to know what this numerical is given. Okay. So, first, what are our given data? We need to understand. So, our here internal diameter is given by one diagram. We will solve, like here if it is the cylinder, let it is your cylinder. So, what is given? Your internal diameter is given. So, this will be our 280 mm. Next, what is given? Our internal pressure, that is 2.56 MPa. So, as this cylinder is filled with high pressure fluid, so the pressure is what? 2.56, right? So, next one, find the thickness. The question asked about your thickness. We can write or di equals to 280 mm. Next, our internal pressure, that is 2.56 megapascal. We need to find out what? T. To find out T, what we need? Our hoop stress or longitudinal stress. So, here the hoop stress and longitudinal stress is given. As we know, what? Sigma C equals to what? 75 MPa, that is PD upon 2T. Our sigma L equals to 45 megapascal, that is PD upon 4T. So, by this we will find out what? Our T. So, by solving this, C equals to PD upon 2T, we can write T equals to PD by 2 into sigma C. We can write it. So, what? Our pressure is given, what? 2.56 into diameter is what? 280. Next is our sigma C. 2 into sigma C is what? 75. So, now we can solve. E equals to 2.56 multiply with 280 75. Okay. So, 2.56 with 280, what? 71.68 divided by 2 into 75. What? So, next 71.68 upon 0.47. T is in your what? Mm, right? So, if the calculation is any wrong, you can cross check it with this formula also. Okay, so as we have what? Our longitudinal stress. So, you guys can cross check with this formula also. Here, by putting in numericals, we just need to understand the question. What data we have. By if we understand the question, next what we can do? Just put the value and get the answer in our formulas. So, in our second question, what was given? That thin cylindrical closed as both ends. Okay, the cylinder is closed from both ends. That means there is some pressure. So, here your internal pressure is 2 megapascal. Next is your diameter. Diameter is given here. And the wall thickness is also given. Thickness is in mm. So, we need to convert this meter to mm. As we know, 1 meter equals to 100 centimeter and 1 centimeter equals to 10 mm. So, we can write 1000 mm. Next, what was the question? That maximum shear stress in the cylindrical material. So, how to calculate maximum shear stress? If we have sigma C and our sigma L, one is maximum and minimum. So, we can write tau max is our maximum stress, that is sigma max minus sigma minimum by 2. So, here we can write sigma C minus sigma L upon 2. But writing the formula, we can solve it like PD upon 2T minus PD upon 4T by 2. So, what we got? PD by 4T into 1 by 2. So, for tau max, we have the formula as PD upon 8T. Right? Also, we can do in another process what? We can find out sigma C and sigma L. Then we can put this formula. Sigma C minus sigma L upon 2. Also, we can find out this. So, as we have P, D and T, so we can put the values and we will get the answer. What? 2 into diameter is what? 1000 upon 8 into your thickness. $25. So, here your tau max is equals to 25 megapascal. Okay. So, in this numerical, what we learn? How to find out our maximum shear stress. So, in our next question, what I have given in this question? A spherical cell of 1 meter diameter. So, first we have found out our diameter of the spherical cell, that is 1 meter, subjected to an internal pressure that is 0.5 Newton per mm square. So, P is our 0.5 Newton per mm square. Find the thickness if the allowable stress in the material of the cell is what? 75 Newton per mm square. Here allowable stress is given. So what is the allowable stress? Allowable stress, we take it as our longitudinal stress. If our permissible stress is given, then we will take that our hoop stress. In next classes, we will learn about what is permissible stress, what is allowable stress, what is ultimate stress. We will discuss about that. So, our sigma L is what? 75 Newton per mm square. We need to find out our thickness. Here we have the value in Newton per mm square and here also in Newton per mm square. So we need to convert this 1 meter to mm. Okay. So now by putting the values in our formula PD upon 40, we will get what? 75 equals to 0.5 into 1000 upon 4 into T. We can write it like this: 0.5 into 1000, 4 into what? Our 75. So now by using the calculator, if you guys do have scientific calculator, you can directly calculate. What we have? 5 by 3. So the thickness of the material is 1.66 what? In mm. Okay. So as we have here what? Our thickness and diameter. So in our first class about when we learn about what is thin cylinder, I have tell you what? T should be less than D by 20. Then that will be our thin cylinder. So you can check from these values T and D if here the spherical cell is thin cylinder or thick cylinder. Then you can comment me in this video. Okay. So in our next problem, here we will understand this. So what was in given data? Here asked is, the question asked us what? Thickness. Thickness of the pipe due to an internal pressure. So the internal pressure is what? P is equals to 10 Newton per mm square. If the permissible stress, here the permissible stress is given. In our previous question, allowable stress is given. So permissible stress is what? Hoop stress, that is 120 Newton per mm square, and the diameter of the pipe is given, that is 750 mm. So as here all these dimensions are in mm, so we don't need to convert it. Also PD upon 2T. As we need to calculate what? T, that we can write PD upon 2 into sigma C, right? So our T will be P is your what? 10 multiply with 750 upon 2 into sigma c 120. So 10 and 20, okay, we have 750 upon 24. Here our thickness is what? 31.25 mm. If there is any mistake in calculation, you can cross check it. Okay. So in this class we have already solved 4 numericals based on your hoop stress and longitudinal stress. Okay. So I think you understand it properly. If there is any issue, you can ask me in our comment section. Thank you so much.